Hey everyone, welcome to the 12 Labs Pegasus 1.5 live demo. Today we're going to go through the latest version of our model, which takes videos natively and turn them into structured format. I'm Aiden.
Hey, I'm Travis.
Hey, I'm Kian.
So before we get into what we have built, I want to take a step back and explain why we built it. Video takes 90% of the world's data. You can search text, you can search image, but you still can't reliably extract what happened at 1 hour 47-minute mark of a 2-hour broadcast video in a structured manner. What that means for humans is that you don't know what's inside your video library. In the agentic era, that means agents don't know neither. And the reason is that unlike other data modalities, video is more fundamentally complex. It has temporal axis. 30 frames per second equates to roughly 100,000 frames per hour. It's natively multimodal. It has not only the visual frames, but also audio streams. And on top of that, the diversity of video content means completely different ways to extract meaningful data for each content type. For example, a security camera may have one meaningful event every 24 hours. A fast-paced sports game may have one every 10 seconds. And all of these characteristics makes it extremely hard for the models to reliably understand videos. By its nature, why video is unstructured.
So when customers first come to us and ask, how can I enrich this vast archive of unstructured videos? The very first thing they ask for is, okay, can I at least get a high-level summary per video? And this is something that we were able to do with the previous generations of models. So for example, 3 years ago, we released Pegasus 1.0, and about a year ago, we released Pegasus 1.2, which are mostly video Q&A models. So you could ask it a question, it would return a factoid answer. These models, we were able to generate summaries that would encapsulate a high-level view of a single video asset. However, once customers got used to having summaries per video, they quickly realized that they want to go deeper. Even inside a single video, there are multiple segments where the semantic meanings actually differ. So they want to capture that fine-grained information as well. What they ask now is, can we segment the video into meaningful chunks and then extract metadata per chunk? Now, this is a fundamentally more complex problem than just answering a simple question about a video, because it requires outputting a set of segments, each enriched with metadata associated with that specific temporal duration. So technically, while Pegasus 1.2 can be used to solve these kind of workflows, it forces the customer to go through many hoops just to make the pipeline work. And we realized that if this is what the customers actually want, we should just build Pegasus 1.5 to be excellent at this specific task instead of forcing the customers to engineer their own pipelines.
Kian, like you mentioned, this all came sort of from the perspective of a customer, what a customers actually need to do. When we think about sort of who we built Pegasus 1.5 for, it falls into many different categories, but I can give a few examples of what customers are actually wanting to do with Pegasus 1.5. So if you imagine that you're a very, very large news broadcaster, you might have an archive worth of footage, and some of that footage might already be alive and on the cloud, but a lot of the broadcasters have been around for a long time, and a lot of their footage is sort of sitting on-prem, not easily accessible. And ideally, as we're taking and we're modernizing this footage and we want to put it up into the cloud, we would love to have a way to actually give that data structure so you can know what's inside of it. If I have 1 million hours of video, I don't want it to be the more video I have, the more difficult it is to do anything with it. I want it to be the more video I have, the more value I can actually extract out of that. And that all starts first order with the ability to actually give structure to that content. And so if I'm migrating that news archive, I might want to actually lay in a custom way of segmenting my content. So it's not just about, can I segment the content? It's about, can I segment the content in a way that suits my business, that suits my use case? And then beyond the segmentation criteria, defining how you segment the content, we actually want to be able to specify the custom metadata we want to extract out. These can't be fixed fields because fixed fields don't actually accomplish what businesses need or what customers need. They need to be able to mold that metadata to suit their exact use case. So that means you need to be able to specify custom metadata schemas and define what each of those metadata fields actually represents so you can extract it out in a way that's useful for what you're trying to build. This also carries over to sports as well. So sports is even more complicated than news because of the intensity of the motion, all of the temporal complexity is amplified because of the fast-paced nature of sports content. And on top of that, it requires domain-specific knowledge as well, too. So a lot of the academic models that might exist today are good at general sort of purpose, but when it comes to domain specificity, they lack the actual knowledge or training data to be able to execute on that properly. So we wanted to partner with our customers as well, too, to not only sort of bring that segmentation and custom metadata specification, but make it well suited for the content types they're actually operating on. And when you think about what all of this looks like, we have it wrapped up in sort of a nice, easy to use product package that we'll go through here in a demo in a little bit.
As Travis mentioned, time-based metadata is really focused on actual business use cases. So the very first roadblock that we faced when we were building this product was that we didn't have any existing evaluation frameworks. Either were too simple and focused on Q&A style videos, or they were using videos that were far too short to actually meet production requirements. So the very first thing that we did was build our own eval data, and that meant getting the actual videos that we need, getting the proper and accurate time-based metadata annotations, and going through manual human validation for all of the eval data sets. Once we had the eval data sets, we also had to define the metric as well, because time-based metadata is essentially comparing a set of predicted segments to the ground truth. It's not about comparing a simple string answer. So we had to define a really accurate metric to quantify how good the model was at predicting these set of segments instead of just being able to quantify simple answers. Now, I mentioned that we had to define our own metric as if that was some kind of a burdensome task. It actually isn't. While it is very time-consuming to have to build your own eval set and also the metric, because we had full control over how we quantify the quality of the end-stream task, we had very good synergy with advanced training methods like reinforcement learning with verifiable rewards. So the key property of that specific training methodology is that your scoring function, your reward function, has to be verifiable. Now, normally people use proxies that are easily verifiable, but slightly different to their end goal because of that constraint. However, because we can design our own metric end-to-end, we made sure that our metric that was quantifying the quality of the time-based metadata were verifiable from the get-go. So we didn't need to rely on any other proxies to utilize reinforcement learning, which made utilizing reinforcement learning with time-based metadata really easy because we were directly using the end metric as the reward function instead of using a different proxy. Through all these consolidated efforts of building our own eval data, our own metric, and then further utilizing the metric to have great synergy with reinforcement learning, we were able to improve the baseline performance from the low 40s into the high 70s really in a fast manner. Now, there were some moments that were really surprising for us during this journey. And the biggest thing was how good reinforcement learning is at hacking the reward function. So the way reinforcement learning works is we incentivize the model to increase the score of whatever reward function we are using. But since the model doesn't really have any context on what this metric function is trying to do, it finds any and every way to increase the score, even if that means that the performance isn't actually getting better. So because of that, we have to go through multiple iterations defining the time-based metadata metric because the model kept finding ways to increase the score without actually getting better. This was a clear sign of reward hacking. So we went through multiple iterations where we first had a definition called temporal coverage, where we measured quality by just pure duration. So we had the total duration of ground truth segments, and then we would measure how much of it was covered by our predictions. But the model quickly learned to hack this kind of metric, maximally predict segments with no regards for precision. Because of this reward hacking behavior, we had to define a temporal duration version of precision and recall and use a temporal F1 score. So the model would not just be able to maximally predict segments and still get us increase in score. Reinforcement learning ended up doing two things for us. Was one, it improved the model performance as a secondary training stage, but also more importantly, it was battle testing our metrics because it's not a metric that someone else tested. It's something that we also defined. So through RL, we were able to improve the model whilst also making sure that our metric was in line with the actual downstream performance and not just giving us higher scores for nothing.
We talked about Pegasus 1.5, but we definitely sort of want to show what Pegasus 1.5 can do. So what we have on the screen here is a lightweight UI that we constructed that wraps the API that you can access Pegasus 1.5 through, just to sort of show the capabilities of Pegasus 1.5. So one of the table stakes things that you absolutely have to be able to do if you're going to be able to claim to segment content and then actually produce time-based metadata is to do speaker diarization and segment when speakers change. This is unsurprisingly a really common request that we get from customers. And ideally, we want to be able to do this type of thing very easily. So what I have here on the screen is the output, but I'll show you sort of the structured input that we give to Pegasus 1.5 to produce this. So at the top here, we actually have what we call the segment definition. So the segment definition, if you remember what I introduced earlier, is sort of what is the custom way I want to segment content as the end user or the developer. It's going to be specific not only to my content type, but also my use case. So here I want to segment whenever the primary speaker changes, and I want to create a new segment for each speaker turn. So in this scenario, we'll have an interview, but you can also imagine this happening during dialogue conversations in movies, during streams on Twitch, things like that. On the speaker label part, we want to actually identify who the speaker is. And we don't want some generic label like speaker 01. We want to actually use some of the information from not just the audio component, but the visual as well too. So here we give the example of first reporter, first interviewee, things like that. And it's a little bit more specific probably to what I want to use my metadata for downstream. Then we have, sort of the vanilla transcript summary. I just want to know what was kind of said at a high level in this particular segment that we're generating. And then for the speaking context, I want to sort of limit it to a controlled vocabulary. So the other thing, if you remember what I said earlier, is customers usually have their own sort of metadata they want to generate. And oftentimes this metadata comes in sort of two forms. One, we can have sort of these more open-ended outputs that are more specific to the actual content itself. But then we might have what we call these controlled vocabulary fields. So these controlled vocabulary fields are basically a list of fixed possible outputs, or enums if you're sort of computer science background, that you want to fix the model to be able to output. So here we only want to allow Pegasus 1.5 to choose from these 5 options: interview, narration, dialogue, presentation, commentary. So after I actually submit this API call to Pegasus 1.5, the output I get can be visualized here on the screen. So on the bottom, we actually have these clearly defined segments of every time there's a speaker turn change per the segment definition. And then you can see sort of the total coverage that we have. So in this case, because it's a news broadcast, most of the content is actually speaking. So it's unsurprising that we get 96% coverage. There are sort of a few gaps that we'll look at here, but if I play sort of this first segment,
to do more than he's doing now, and I find it a very big chance to do that. And I suppose everyone...
You'll see as we switch from segment 1 to segment 2 that we switch from the first interviewee to the first reporter. And we get a sort of targeted transcript summary of that segment specifically. And if I sort of jump here towards the end of this segment and play from here,
The Lady Diana, Princess of Wales Hall, celebrating Harry and Meghan's marriage today.
Thank you, Raggy. Thank you very much. Let's get a...
You'll notice that we switch from this first segment to the second segment, even though the first interviewer or the first anchor was on screen and somebody else started speaking. Visually, the same person was on screen, but because we define the segment definition to focus on the audio signal more as opposed to the visual signal for actually creating the segments, we don't get the new segment created until we actually get this individual here, which is the studio anchor, to start actually speaking. And if I play sort of through this piece here,
Throughout the wedding, they were cheering everything.
here you'll notice that we get the speaking content to be narration because this is no longer sort of an interview. And so you can sort of maybe parse that from the transcript, but the visuals certainly help to illustrate that this field reporter is narrating basically over some B-roll type content in the background, and that's actually what we sort of want to have when we have the speaking context field here. So we'll actually switch over to the second demo here, which ironically is a little bit sort of like the needle in the haystack that Kian described as the original set of questions, or the original set of functions from the models that used to exist before Pegasus 1.5. You still want to be able to actually segment out very targeted parts of the video. And in this case, we'll go to extreme and produce only one segment, but it's really to actually highlight another component of Pegasus 1.5. So if I look at this segment definition, we have a few interesting things going on. We have the segment definition here, which is I want to segment on a specific product and specifically where it appears with other products on the screen. So compared to the first demo, which heavily anchors on the audio signal or the audio outputs to actually produce the segments, here we're doing the exact opposite. We want to focus on the visual aspect as much as possible. And so this is leveraging the two sort of distinct modality contributions that video comes with. And you'll notice that I actually have sort of this at reference in the definition here. We're actually using an image as part of the input here. So this is what we sort of call composed prompting or composed input, which is where we're sort of interleaving, the text instructions along with a visual representation. And there's a lot of complexity in this that I can chat about with Kian here in a second. That was quite fun to figure out. But the sort of interesting part here is I just want to find where this product appears. Now, this product only appears once in the entire video. And you'll notice this video is 18 minutes long. So we're actually looking at the entire timeline, and we're only getting 5% out. And so if I jump to this segment here, There's actually no audio in this video even, but you can see we actually segment exactly where this product is. And even as it sort of becomes partially occluded from the front and goes around to the back, we maintain that this is still the same segment as it comes back around again. And so we find this sort of needle in the haystack. And Kian, I know that you and the team went through a lot of trial and error to figure out what was the most appropriate way to bring this type of composed functionality to Pegasus 1.5. So I think it'd be actually pretty cool for you to talk about some of the things that you guys had to overcome to do that.
Yeah, so like in this day and age, I think what we figured out was that ultimately it reduces down to correct token placement. So it's very tempting for us to think of images and videos as the same thing, right? Like, oh, videos is a sequence of images. So the tokens from the videos and images, maybe we can just treat them as a single visual token. And while that makes sense and is very tempting and it simplifies the architecture a lot, we actually found out that treating images and videos as the same thing actually breaks when we want to do these kind of composed segment definitions. So architecturally, we had to treat the tokens from images and tokens from videos as separate things because they are indeed two separate things.
Yeah, this is the, like moving the haystack, needle in the haystack, multiple segment definitions, it's sort of culminating. Here we have a significantly more complicated use case, both in terms of what I want to actually accomplish as a developer or user, and also the content type itself. So the content type itself is complicated for so many reasons that we'll get into here in a second, but this is going to combine many things together all at once. So you'll actually notice on this particular demo, we have 3 timelines that are being output here. And this is because for Pegasus 1.5, we wanted to design it in a way that customers would actually use it. And most customers don't want to just produce one type of segmentation or one type of metadata output that's anchored to that segmentation. Most customers' use case involves a sort of complex metadata generation pipeline, and we want to be able to execute that sort of in one pass with Pegasus 1.5. We don't want the customers to have to do multiple API calls. So what we're actually able to do in Pegasus 1.5 is define multiple segment definitions. So here, you'll see that I've defined 3 separate ones. I kept some of them simple just so we didn't have too much to look at on the screen, but it will still illustrate what you're able to actually do with multiple segment definitions. The first one is gameplay footage. So this one starts off pretty simple. It's just I want to generate segments only when the content on screen is not actual gameplay. So I want to have a description that's output as the metadata for this. But this is pretty common because if you think of broadcast sports content, there might be replays, there might be B-roll rolled in, there's commercials, and if I just want the juicy, meaty parts of the content, I need to be able to actually separate all of that out. So this is something that we see pretty commonly. The second one is probably more what people would think of when they're actually watching this type of content, which is I want to look for the most exciting parts of the gameplay, which tend to be scoring plays or something else like fouls and things like that. But in this case, I've defined the segment to be anytime a team scores points. I'm not giving too much context to the model here. I'm just sort of saying any type of scoring event. So that could be, as we'll see here for the basketball content, it could be a 2-pointer, a foul shot, any of those things. And then the segment should be the entire scoring play. So this is nice because it's actually going to give me that temporal context that I want around the event. Simply just determining where the ball goes into the hoop is insufficient for a lot of customer use cases. They actually need that content around the target event because they're going to use it for downstream tasks. So if I'm trying to put together a highlight reel of the best 2-pointers from the season, I need the entire play, not just the exact moment where that happens. Although in some cases you may want the exact moment, but you can also change the segment definition to gear towards that as well too. Here I've defined 3 different metadata fields for this segment definition. I've defined points scored. That's pretty self-explanatory. Here for the sake of the demo, I've limited it to 3 options, which are 2-pointer, 3-pointer, or 1-pointer, which is fairly representative for basketball. I've categorized the shot type, and here I've limited to jump shot, layup, dunk, or foul shot. But you can imagine having a sort of full controlled vocabulary here again. And then I put the scoring team. Now you'll notice that I don't actually give an enumerated value here because we want Pegasus to sort of figure out what are the 2 teams and which one of those 2 teams scored. Then the final one that we have is actually camera cuts. So I want to know every time the camera changes, both from a hard cut perspective, but maybe also from a few other things as well too if I wanted to change the segment definition. In this case, I'm going to do it on hard cuts, and I want to know what the camera angle is every time there's a hard cut. So is this a high angle, low angle, or a medium angle? Now, if we roll all of that together sort of into the mother of all demos here, we can't actually just leverage any single modality to execute on this. We need both the visual signals and the audio signals, and we absolutely have to have the temporal awareness over that, not just for the local segmentation, right, but the global segmentation as well too. So as we'll see in this content, this is extremely old footage. It's black and white. There's not traditional graphics overlays like you see on most modern broadcast footage, which means that the model can't really rely on OCR or anything else like that in a way that you could with modern content. And then on top of all of that, we really only mention, right, who the teams are involved, both at the beginning and then periodically for the narrator throughout. So as we're generating the segments, we have to take all that into account to, one, generate the actual correct segmentation boundaries, but then incorporate the appropriate local and global temporal information to produce the coherent metadata. So as I'm playing this video here, we'll focus on the gameplay footage first. Right, we have a cut here on the non-gameplay footage, and we've created two different segments, and that's because, right, these are two very distinct shots. The first one was of the title page here, and the second one is actually a wide shot of the crowd, but both of them actually fall correctly into the segment definition, which is non-gameplay footage. And here I'm giving the description of what this is because I may want to use this footage for something else. Now, on the camera cut perspective, we also see that this lines up here as well too. Right, we have the camera cut and then we switch over here. So in this case, these two things line up. Now you'll see as we look at the rest of the timeline that that is certainly not true. This is sort of a coincidence at the beginning. And this is something where even models that can output multiple sort of time codes and not strictly in a Q&A fashion really don't execute well in this use case, which is where we have boundaries that are discordant from each other. So they don't line up very well. Most of the sort of model capabilities that exist right now make it very difficult for you to output segments that overlap with each other. Sometimes, not all of the time, maybe 100% sometimes or not. There's a lot of sort of infinite tail edge cases that you can run into. Here with Pegasus 1.5, we approach that foundationally from the model architecture, thanks to Kian and the team, and we're able to produce these discordant outputs that don't degrade the performance of the independent segment definitions. And I think the most interesting one here, at least for me personally, is looking at one of the scoring ones. And I'll pick one out here because I think this is the most representative of what we want Pegasus 1.5 to be able to do, which is there are only a few scoring plays in this short highlight reel here that we have from, I think this was a 1960s game. Let's see here. Yeah, 1963 here. And ironically enough, this is before the three-pointer was introduced to basketball. So you'll see in this content as I'm playing it here, there is no three-point line. And on this particular example, remember the scoring plays segment definition is I want to know when a team scores, and I want the segment to be the entire scoring play. So it can't just be right in one giant segment because it has to focus in on the play. So as I watch this buildup of the segment here, you'll notice that there are multiple changes in possession, and there's only one scoring play at the end of all this. So I'll play it here after the first change of possession, where we have a fast break to the other end. The ball sort of goes off the backboard, and there's a change, and then there's another fast break. And here, this is where we actually have, right, the actual scoring occurring. And we correctly identify that the team is Loyola, and this is a 2-point play, right, because this is a layup. Now, this entire portion here was not identified as a positive segment because although there were plays and there were changes of possession, none of those plays were scoring plays. So when we finally get the last change of possession and we have the scoring event occur, that's where Pegasus 1.5 actually decides to create a segment, which is the exact sort of thing that we're looking for based on the segment definition. Now, if you think about sort of how powerful all of this is for this type of content, this is black and white footage. There's no OCR, there's no graphical overlay. And this is the type of content that actually lives in a lot of our sports customers' archives, right? It's historical content that there might be nuggets that are incredibly awesome shots to actually have, but it might be very inaccessible. And so the first order thing that you need when you want to sort of bring your content alive and make it searchable is this structured output. But with video, you have to have the time-based element to it, or else it's completely untenable. This is sort of, right, a short clip from this game, which is about 2 minutes, but this entire broadcast, right, was probably multiple hours. And so I need to be able to know exactly where this is and have the correct temporal boundaries around that. And then sort of all that together, having all of the segment definitions that I want up front from a single API call makes this sort of a nice, seamless developer experience to actually build pipelines around this. And you guys probably, right, had like the most fun with this part, because this was where the science team, which super thankful for them, got extremely close to our customers, both sort of listening to what customers had to say, looking at data sets with them, understanding what the customer really wanted, and then actually incorporating that into Pegasus 1.5 as a whole. So if you could go through some of like what made this type of content the most difficult, that would be awesome.
Yeah, I mean, as you showcased here, there's a whole bunch of things that people are interested in about sports content. So it's not just we can only be good at this specific aspect of sports video and it's fine. So we have to really acknowledge the fact that customers want a very wide array of metadata and very wide array of segment definitions for sports content. And with most deep learning models here, almost everything is backed by, it should be backed by data to actually have the capability fundamentally. So while it's very tempting to just propose a quick architectural change to maybe have a cheat out the capability, it's actually fundamentally important for us, for our training data and eval data, to properly reflect all of these intricacies and varieties that is actually required by the customer. So what we ended up doing was we made a system where we took the customer feedback and made it directly embedded into our training and eval data curation processes. So it's not just words, right? So it's not just like, oh, we acknowledge that this customer needs this and we're gonna build it, sometime later. It's not that. So the knowledge of what the customer actually wants and the business use cases is embedded into the training data pipeline systematically. So it's not up to any individual to carry this forward. We built a system where the customer needs are properly fed into the training and evaluation data pipelines, so that our models can continually improve and fundamentally have this capability that is directly traceable to any single customer request.
Yeah, absolutely. And I think that carries over very clearly to these types of use cases. And I know we're super excited for Pegasus 1.5 to finally be released and see what everybody builds with it, because we focused right on sort of trying to bring a very generalized framework for people to be able to apply this to multiple content types. I know we had some customers in the beta that we didn't anticipate sort of participating, but even for those customers that are a little bit outside of the target area, I would say, we've heard good feedback, especially in comparison, right, to the previous generation of models that currently exist. So huge thank you to you and the science team for working with the customers to be able to make that happen.
No, thank you for bringing in all the feedback. Travis, thanks for walking us through all the demos. And I think it's really interesting because the demos really highlight the duality of the video content. It's both sparse and also dense, right? So you've seen demos where we had to pick a very specific segment out of a very long video. Some would call that a needle in a haystack kind of capability. But we also see multiple instances where we're interested in like the entire video itself. So it's not just about picking a specific location inside a video, right? So it's almost as if like it's a needle in a haystack, but we're not interested in just the needle. We just want to organize the entire haystack itself.
Yeah, that's exactly right. And I think the analogy fits pretty well, because sometimes you do just want the needle, but sometimes you have to rearrange the haystack into different piles of different sizes for different purposes. And you mentioned, right, sometimes it's dense, sometimes it's sparse. And I think that's a lot of what we see on the customer use case side, right? So if you think about media and entertainment, right? One segment might be, I need to know every time there's a hard cut, and then I need to know the camera angle, like we showed in the sports demo. And in that case, right, like it would be like 100% temporal coverage, because everything is focused on, I have a shot, there's an angle, and then there's a cut. In other cases, though, right, if you think about, I want to segment every time I see this actor on screen with sort of some of the composed stuff that we built, that would be a lot more sparse, right? Because the actor isn't always on screen, especially if it's not a leading actor. And they might have significantly less screen time, and so then it becomes more and more sparse. Or you might be looking for incredibly rare events, right, and like surveillance footage or things like that, and then it becomes even more sparse in that case. So those are a lot of the things that we tried to consider when we wanted to actually make this into the model, which then we sort of built the product layer around as well too. So I think the one thing that we really wanted to think about from the product perspective, other than all the things that we've already covered, is when you think about what customers are actually going to do with this, it's going to be, I have a lot of content and I need to create structure around all of that content, basically. It's never almost never I have a single video and that's all I care about. It's I have 10,000 videos or I have 1,000,000 hours of video and I'm doing something with it. And so that's one why we designed the multiple segment definitions, because you want to do that as easily as possible across all the things you need to segment on. And then two, we've set Pegasus up to be able to scale up for sort of batch ingest and things like that as well too, with the way that we've designed the asynchronous API structure itself. So this allows you to be able to submit, queue up a bunch of time-based metadata jobs in the queue, and then actually execute on those. And that sort of is geared towards allowing people to take a bunch of content, process it through the pipeline, and get all that structured output in a predictable fashion from everything that we've sort of just went over today.
Now, Travis, we talked about lots of things, how this new model can impact humans. But now in the agentic era, this has huge implication to agents as well, right? Once video is structured and accessible through this API, it now becomes like first-class input data for any agent or system that needs to make decisions based on this visual audio content. And this is the future we're building, right? We're building towards a world where video is navigable as text, and Pegasus 1.5 will be that significant step in making that direction work.
Pegasus 1.5 will be available now on our platform. The full API reference you can find at 12labs.io. There's a free tier, no credit card required, you can just start whatever. And honestly, we love the feedback, so please experiment with Pegasus 1.5 and tell us everything you liked and potentially didn't like about it.